Hello guys. So one thing I want to get into before we start setting up our router is static and dynamic routing. We're not going to be covering how to do static routing in this video, but we'll just talk about it because it's useful to just understand what static routing is. Basically, static routing is where someone like a network administrator would manually configure a router to send traffic to particular destinations, unlike its counterpart, dynamic routing. And dynamic routing uses different routing protocols, which we're going to cover in this video, such as OSPF, ERIGRP, and RIP. And basically, these protocols they replace having to manually enter all these destinations and does them for you in different like routing tables and stuff. And they update and everything depending on the situation of the network. So that's just basically the differences between like static and dynamic routing. We're only going to be covering dynamic in this video. Today we're going to be looking at how you set up a router first before we get into any sort of protocols, because setting up is really important and I'm going to tell you why. So one of the first things you're going to have to understand is that in the ISO model of Cisco there is a hierarchical structure. There are many different levels of the hierarchical structure. First off, there's just the basic user structure, or the user tier, and in there you can only do you're very limited. You only do things like ping commands and stuff like that. Next you go into the what we call the privileged commands, and in there you can do all sorts of different things mainly you only want to be in that mode, but in that mode you can see your IP route, see your routing table, or you can go into the next mode, which is a global configuration mode, which is where all sorts of things like your IP address and what interface you want to put it on and which routing protocol you want to use for the router can be configured. So first of all, we're just going to show you how you can actually set up a router professionally. So we're going to just pick a router out here, drop that into there. So I'm doing this in Cisco Packet Tracer, but the tips in this video still work for the same on a real Cisco router. It's just this is more easier to capture than a Cisco router. So I'm going to go into here. It's going to open up a little window. First I'm actually just going to rename this router. So I'm going to call this one the UK. I'm renaming the routers just so they got distinguished names and they all don't look similar, like route 1, route 2, route 3. So here is the UK router. And first off, for Cisco Packet Tracer, you're gonna have to make sure we've got some extra ports. Basically we're gonna want some serial ports in this router for what we're gonna do later on. So how you do that is, first of all, you're just gonna turn off the router with this little power button here. Turn that off, and then you're gonna go over here, and because we just want 2 serial ports, we're just gonna pick the HWIC-2T. which you can see a little preview of it down there, and it's got 2 serial ports on it. So you just go drag that into there like that. Turn on the router, and now if I just close that down a second, you will see if I go try and plug a cable into it that there are now 2 serial connectors, but we don't want to plug a cable into it just yet. So we're going to go back to the CLI command line interface. So when you come into here, you're going to want to set up your router, and you're just going to call this, you're just going to say no on this dialog box. So as you can see, currently it is called router. We're going to want to change that host name to the UK like we've called it on the map. So what you do is, you're going to, first off, you're going to want to go to privilege mode, so you're just going to type in enable, and next you're going to want to go to the global configuration mode. So you're going to type in config t. You can also type in other commands like configuration terminal or conft. I've seen that word, but I prefer config t. It's my personal preference. So now we're in global configuration mode. We can now change the host name. So you're going to type in hostname, and then the name of the router, what you want it to be called. So you type in UK. As you can see now, after we've done that, it is actually configured down there. That's all pretty nifty. Now we have our name. But next, if you're in a professional environment, you're going to want to include a password, to stop people getting onto your server and other things like your router, and seeing what IP addresses or what, and messing around with it in general. So next you're going to want to put a password in. So next you're going to want to type in enable secret password. I'm just going to do that now. Like so. And remember, first rule of actually enabling a secret password, spell secret right. So as you can see, if you do get the command wrong, it does make it clear that you have obviously done something wrong. Not so good at telling you what you've done wrong, but it tells you you've done something wrong. So if you've done nothing wrong there, it just goes on to the next line. So next you want to type in line console 0, like so. And then we're going to want to put the password in that we want to use. So for being basic during this video, I'm just going to call the password password. So type in password, enter. Then we're going to type in login, and then we want to type in line VTY04. Now after that we want to put the other password in. Well, password again for password. So we'll do that. Type in login again. Right, and that is the passwords done. So one of the next things we're going to want to do is we're going to want to set up a banner on our network before we start adding any IP addresses or anything like that. I mean the banner on the router. So how you're going to add a banner on the router is you are going to just get out of this. You can type end to get out of this, because in global configuration modes there are also 3 different types of sub things in global configuration mode. There are interface commands for the router. There are also routing engine commands. These are these go into things like RIP and what version of RIP, so you can use RIP 1, 2, all stuff like that. And there are also line commands, which you can see as we've just used now to set up the password. So we're going to click end, and we're just going to get it out of configuration line. So as you can see now, we are back with this little hashtag here. We're just back in normal privileged things. So you're going to type in configuration T, that, and next we just want to set up the banner. So what we're doing now is to set up the banner, we are just going to type in banner, MOTD, and a good way to remember this is you can remember it with an acronym like message of the day, MOTD. Then you're going to put a hashtag in. There's a hashtag. You're just going to want to say something like this is the UK router, hashtag, to close the message off. The main idea behind doing this is if you've got no message on your router and someone comes in and configures it and messes it up and everything, they can say that it was they didn't know it was your router or something, and they can avoid being lost stuffs that I don't understand. But this secures you for that. You can say, oh, this is my router, stay off my router, go and use your own. So now we just click enter, we save, we do that. So I'm going to try to type end in again. One of the next things you want to do is, when you are making any sorts of changes to your router, is saving the changes to your router. So to save any changes to the router, you can type in copy running -config space startup -config. Now this means it's going to save the running configuration and use this running configuration on the startup. So we're going to click that, and it's going to say destination file name startup config. Yes, we do want that. So now it's built the configuration. That's all fine and dandy. So what we can do is now we can type in exit, and you can see here straight away it says this is the UK router. User access verification. It's asking for a password. So as you know, before we set the password, let me just type that in. It's not going to show on the screen because it's password. And yeah, you can see that I am now in like the router, and I type in enable password, and there we are. We're now in enabled mode. Now there shouldn't be a password for getting into configuration mode once we've gone through the 2 password blocks. Yep, so basically before when we were setting up the passwords, we set up the passwords just to get onto the router, and then the passwords for accessing the privileged mode. But we don't need a password for the global configuration mode. Right, so next thing we're going to do is we're going to set up the router with an IP address, because it's the whole point of having a router. And we're just going to set the router up with an IP address now. So I'm just going to put another couple of routers in, just to show like how we could, you know, a connection and all that. So here we are, just going to connect this one up with the serial. Almost forgot to add some serial ports there. Just going to plug that into serial port 0 and plug it into serial port 0 this side, just to make things easier for us. So now we've done that, we can now begin to start adding our IP address. So what you're going to do is you're going to type in, once you're in global, you need to be in global configuration mode for this. You're going to type in interface, and then it's going to want the type of interface that you're using. So in this case we are using the serial interface, so you just go type serial, and it's going to want the actual number of the number of the serial port on the router. So as you saw before, we plugged it into 0/0/0/1/0. So this is basically just configuring the IP address on that part of the router. So now you can see we're in config if mode, which is the interface command section of global configuration mode. So now to add an IP address to this, you go type in IP address, and then we're just going to put in 192.168.1.1. Then we're going to put space, because we're going to put the subnet mask in, so space 255.255.255.0. That's just the basic IP address. You click enter, and then you can put a description in here if you want, if your IP address, but we're not going to bother with it for this tutorial. So next we're going to type in no shutdown, and then this will change the state of the port from down to up. So just type in no shutdown. On here you will see that its serial state does say that it's changed to down. Don't worry about that now. That's only because the other side of the serial, like the other side of the connection, is not actually got an IP address and turned on. But once the connection on the other side is turned on, that one will also turn up as well. So now we've got our IP address in. We're just going to want to save this like how we said before, so we're just going to type in end there, and we're going to be copy running -config startup -config. Save that built. Right, so now I'm just going to skip ahead and configure the other router. I'm not going to bother putting a password on it or a message at the day banner, just because this is tutorial purposes and we don't really need it for that router. So I'm just going to go and set up the other router now. So as you can see now, when I'm about to just type in no shutdown on the USA router, that you will see the 2 green lights on this side turn on like magic. So let's light her up. As you can see now, the state has been changed to up, and we have 2 green lights here with a connected router. And just to show, I'm just going to save. You can see everything's changed up. Right, so we're just going to check that these two are connected to each other, and yeah, it is successful. UK to the USA, successful. So next we're going to go on and teach dynamic protocols such as RIP, EIGRP and OSPF. So now we're going to talk about RIP. RIP stands for Routing Information Protocol. An interesting thing about RIP is there's 2 different versions of it. There's version 1 and version 2. What version 2 does over version 1 is that it sends the subnet mask information in the routing table update, whereas version 1 does not send the subnet mask, and it just presumes that every machine on the network is using the same subnet mask, which in the case of with the example I'm showing you today, that is true. So we're only going to be using RIP version 1, but the principles of RIP are the same. RIP was very popular a few years ago, but due to limitations now, it's only used on a few smaller networks. One of the features of RIP is that it has a maximum hop count of 15, and the 16th hop is considered unreachable, and it'll just stop passing the packets around. This is to stop the packets travelling around the network forever. And another interesting thing about RIP is that the routing table updates every 30 seconds, and if no route has been updated for 180 seconds, then Routing Information Protocol declares it an invalid route. So anyways, let's show you how to configure RIP on a network. So as you can see here on my screen, I have expanded the topology a bit. I've put an extra 3 networks in. Each of the green circles includes like a network. So it's the 0.6 network, 0.2 network, 0.4, 0.3, 0.1 and 0.5 network. And then next to the machines and computers and the routers, you'll see these 0.2, 0.1 addresses. So for example, in this, if you were talking about this computer here, this would be 192.168.5.4. And if you were just wondering about what the /24 is at the end of the IP addresses, that is the side notation. It's used in both versions of the Internet Protocol, so version 4 and 6. It basically just counts the numbers of bits in the prefix, and after the slash. So let's move on and show you how to configure RIP on routers. So what we're going to do here is we're just going to open up this UK router here, and we're going to go back to our commands. I'm just gonna, so yeah, still see we've got the passwords on this particular router from before. Yeah. So anyways, so to put a routing protocol on the router after everything's been set up, like your IP address and everything on all the ports, I'll just show you the IP addresses now, because it's going to be good to show you what the routing table looks like before the protocol's been added and what it looks like after the protocol's been added. So what we do is we're just going to do show IP route, and this basically just brings up the routing table. So as you can see, we're currently on the router UK, the UK router, and you see the 0.1 network, the 0.3 network, and the 0.5 network, which is down here where our end devices are. So yeah, and as you can see, there's a little C next to each one of the IP addresses, and if you look at the codes up here, this means connected. Because we're doing RIP, we're going to be wanting to look for an R, which connects the other networks together. So one of the ideas of also using like a dynamic routing protocol like RIP is that, let's say, like a line goes down here, like one of our connections between one of the routers goes down. Let's say this 0.3 network line goes down, but we still want to talk to the 0.4 network over here. So how are we going to do it if that line goes down? Basically, the routing protocol is going to allow us to go via hopping different routers. So you go from the UK router to the US router to the Canadian router, and it would be able to talk to this Canadian PC with that direct line being out, and vice versa with any other line. So if 0.2 line goes out, you go to the 0.3 network, 0.1 network, and you could still talk to the 0.6 end device PC. So we're just going to show you how to configure RIP in the commands. So what you're going to do is, once you're in enabled mode, so one thing I'll show you first is that we can't talk to these other machines via these networks. So what I'm going to do is I'm going to just ping the 0.6 machine over here. I'm going to do ping 192.168.6.2, and the reason we're doing ping is basically sending like 4 packets of data, and they'll communicate with each other and say if we got them or not. And this shouldn't get anything back. It should just time out due to there being no way to talk to each other. But we're going to fix all that with the routing protocol. So as you can see here, success rate 0%. So we're going to fix that now with the routing protocol RIP. So what you're going to do is you want to go into configure T mode, config T. We're going to configure this now. So what you're going to do is you want to type in router, you want to type in RIP. You can type in like RIP v2 if you want to use that, but there's no point for this small network because all the subnet masks are the same. So we're going to type in router RIP, and then we're going to go into configuration router, and then you're just going to type in network. So basically what we're doing is we're just advertising the networks that are available, so it can like go and grab the IP addresses and all that and put them in the routing table. So we want to advertise the different networks. So advertise the 0.1 network, and we're going to advertise the 0.68.2 network. I'll just show you this when it's done. Right, so as you can see now, we've entered all the network addresses in, with spelling mistakes of course. Well, that's okay. As you can see, it tells you that what you've input's wrong, so you don't have to fix it later. So what we do is now we're just going to skip this. What I'm just going to do now is show the IP routing table. You see there's still nothing there, and this is because RIP hasn't been configured on the other routers just yet. So it is, I'm just going to go ahead and configure RIP. It's the same on like every router. Now we've finished advertising all the networks, we should be able to have a look at the routing table. I'm just going to fast forward the time a little bit on here on the packet tracer app, just because it takes time for the routing tables to update a bit. And there we are. We just pop back into here, show IP route, see the routing table, and as you can see here we have Rs. And basically the Rs are networks that aren't like directly connected. So as you can see here, like the 0.1 network is this network here, and it isn't actually directly connected to this network here. But whereas something like this 0.2 network, which is this network here, is connected to the CA router. Same with these other networks here, the 0.5 and the 0.6, they aren't actually directly connected. So what we should be able to do now is just click over here, and we want to send a packet from here to here. Why has it failed? Hello guys, I'm back, and I finally figured out the problem that I had with my topology. Well, not my topology, my routing protocols. And yeah, so I'm going to explain to you what the problem was and why it wasn't working. So the problem was that if the cable was taken out, the idea of RIP is that if something goes down, like a connection point between two routers, that the packets can still be sent through the other router to the other one. But the problem was that this USA router here does not recognise this 912.168.1 network. So it's because when I inputted all the information into the table, or into advertising the networks, that I didn't actually advertise that network on the USA router. So I'm going to show you how I figured out that I hadn't actually done it when I thought I did. So for example of that, we're just going to use the UK router down here, just to show you what one looks like when it is fully clean and how you can check for it. So as you can see now, we're just in the init. We're just going to enable mode, and what you're going to do is you're going to type in show running -config. What this is going to do is going to give you a list of your current configuration that's going on your network. So when you save the network, as we do from the copy running -config space startup -config command, this is basically what it says. It's your current configuration on the router. And as you just keep pressing enter to start seeing more of what has been set up on the router, you will start to see, as we keep going down, that the router RIP will be there. So as you can see here, we have router RIP here, and as you can see, each one of the networks that's on my network is there. So we've got 1, 2, 3, then there's 4, 5 and 6. They're all advertised on this router, but they're not on the USA router, so I'll just show you that now. So we go on here and we do the same again, and we just go show running -config. I'm just going to skip down. As you're going to see here that there is no 912.168.1 network, so we're going to go ahead and actually add that now, so that the network will work fully with RIP. So what we're going to do is we're going to go to configuration mode. Here we configure the terminal. So we're going to type in router RIP. Then we're just going to go and advertise the network now. So we're just going to type in network 192.168.1.0. Then we're just going to end, and we're just going to save the configuration file while we're here, just to make sure everything's saved. There, that's all set up now. Now I should be able to take out this connection from the so basically what I'm going to do now is I'm going to take out this connection, this 0.3 connection, and we're still going to send a packet across to this UK PC. So we're going to go from the Canadian PC to the UK PC, and we're just going to send a packet down. So we can watch this in real time. So what we do is, we're going to just send a packet from the Canadian router to the UK router. I'm going to show you that now. That's going to send there, and it's going to go across that line, whereas typically it would have gone across this 0.3 network line. So I'll just send that back, And yeah, we get a little green tick. Next, we're going to move on to EIGRP, which is Enhanced Interior Gateway Protocol. So, next we are going to talk about EIGRP. EIGRP stands for Enhanced Interior Gateway Protocol. EIGRP is basically Cisco's own network routing protocol. It's basically their version of OSPF, but it's proprietary, meaning that you can only use this protocol on Cisco equipment, which is good if you have all Cisco equipment, but we all don't have all Cisco equipment. But it is one of the best protocols, but some companies will not allow it to be used on their networks due to it being a proprietary networking protocol and not something more open like OSPF. Some of the good sides to using EIGRP is that it is the only protocol that allows backup routes. It remembers the backup routes. Basically, if you're using something like RIP or something, or maybe OSPF, it would only remember the best route. It won't remember any other routes, whereas EIGRP will remember these routes, and it backs them up in the topology, and it's the effect of this backing up also means that if something goes down, it can react a lot quicker than something like OSPF, and it also doesn't take as much strain on the hardware, whereas something like OSPF, it would have to use a lot of process power and all that to figure out the next route. Whereas EIGRP, it's already done the work and it's got it right there, ready to hand over when it's needed to be. And one of the other plus sides to using EIGRP is it just sends changes of the topology out instead of sending the whole routing table like something like RIP would. Another advantage to using EIGRP would be that it balances the loads on parallel lines. So if you can see something here like our network, that let's say this there were two different, these two lines were different. They 1926 point. This one network and the free network had different lines going from them, and they had different bandwidth speeds. So if one was going, like 2 megabits a second, this one was like 1 megabit a second, then it would balance the load to be most efficient. So let's say on the 2 megabit line, you'd get 2 packets going up there to the one that would go on the 1 megabit line, just to make it more efficient overall. Because there's no point having all this bandwidth just sitting around, even if it is just a backup line. It may as well all be used for speed. This technique is called unequal cost load balancing, and it is very efficient for a network. So let's get on with installing EIGRP on our system, on our network, as you can see here. So this is the same network topology as we used in RIP. We'll set up the USA router first. So as you can go in here, we'll just go in here, go enable like we always do. Then go into configuration terminal, so config T, and next you just enable it like the same way you would enable like RIP. So you go router EIGRP, and then one of the special things about EIGRP is you have to put a number after this so that it knows that the routers are all talking to each other in the same thing. A bit like a password, if you will. So yeah, so we're just going to input a number after this. So we'll put 10 in just for easiness to remember. And then you just add the networks like you would on any other like router, like routing protocol like RIP. So let's put the first network in, and same again, we're just going to do this. So as you can see, we've now put all the networks, advertised all the networks on the thing, and we'll go and do the next router now. So we've just ended that. If you're wondering how I'm getting the text back up, like what I previously typed in. You just press the up arrow on the keyboard. It just saves a lot of time if you're doing something like this, type in network and then the whole thing again. Alright, and there we are, that's all them are entered in again. And we just put that in simulation mode again and just delete the scenario. You'll be able to see that this packet will travel to the UK. Successfully connected ERGRP, and you can see up here as well, you can see where the packet travelled from. So the next and last routing protocol I'm going to be talking about is OSPF, which stands for Open Shortest Path First. Now OSPF is one of the most popular, as also more robust and flexible compared to its distance vector predecessors. And one of the things that makes OSPF so fascinating is that OSPF uses something called route summarization. And now when you've got a bigger network, a lot bigger than what I've currently got here with, just these 6 networks, something that's a lot bigger, you're gonna want to make the tables smaller, and that is done by route summarization. The reason you want to make the tables smaller is because, let's say you want to send a packet somewhere on a network, you've got to dig through all this information to know where to send it, whereas if the tables were smaller, it would be a lot quicker to send the information through. So, and the shrinking of the tables is done through route summarization, and so one of the main ideas of route summarization is taking similar routes and grouping them together. So, for example, in this network, you could group this network together because all the IP addresses start with 192.168 and then dot whatever the network is. You could technically group all these IP addresses in. If you were to have like another area of computers with a different IP address, you could just sum these up to that network, and that's done with what we call an ABR router, which stands for Area Border Router, but we'll get more into that in a little bit. The principle of route summarization is loads of routers can be summed up at once. So if, for example, on this network we could have like a router over here, and we could just tap into this network here, and this could be like the router that talks to another router that talks to another network. So we just put like another network in here to talk. So you can see here now that this is like our network here, and then you've got this other network over here that leads off and probably has all sorts of other routers attached to it. But this router 0, which I will actually rename, we will call this, I don't know, call it the A1 router or something. We'll call this A2. So the A1 router would be in charge of actually knowing all of the different IP addresses back here. So, this A2 router wouldn't need to know about 192.168.5.2. Just A1 would need to know about it, and A1 would just advertise that this whole network structure is back here, and then A1 would just take that packet and deliver it to the appropriate address from where it needs to go. So one of the interesting things about OSPF is it uses areas, and areas are groups of routers that have the same information. Like this one here, this can be considered an area. Cisco also says that you shouldn't have more than 50 areas. That's kind of just like an advisory. It's not necessarily that these are the rules. Your network will break if you do not follow the rules. But yeah. So another common thing in these areas is that when you start setting these routers up for OSPF and everything, that these routers have codes. So when you're inputting, you'd type in, oh, this is area 0, for example, and like all the computers on this network would talk to each other. Like, these are all Area 0 routers. And so another typical thing if you was like in a bigger network, like OSPF and like this type of thing is really for bigger companies. So if we were to expand these networks out a lot more, say this was like a world thing, the UK was talking to USA and USA to Canada and everything, that would be a lot bigger network, and this would be where areas would come in. So let's just delete these two for the time being. So I just delete these. So yeah, now we clean that back up. That we could consider areas, if we really wanted to be like here, like this UK network, the Canadian network, and the USA network. And these could be areas. And only you can see on the side of these areas, just imagine there's a lot more back here in each of these networks. But these routers that sit on the edge of the networks are what we call ABRs. And ABR stands for Area Border Router. Basically, these are the more higher spec routers in the network, and they will sit there and they will talk between each other. So like a packet wanted to go from somewhere on the Canadian network to the UK network, it'd have to go here, and the IP addresses would be summed up here, and there'd be a lot more networks back in just this 0.5 network. There'd be like 0.6, 0.7, whatever. There'd be a lot more networks back here than there would just this currently on screen. Just really simple this. Yeah, so this would hold all the routes, and then it would distribute them to other routers, and then it would get to the machines on the networks, etc. So basically the ABRs here summarize in routers. This is basically where the summarization takes place. So like this would only advertise, this point, these certain networks here, and this router up here wouldn't need to know about the 192.168.5 network if this was a lot bigger scale and these were all different areas. So if like UK was Area 1 and Canada was Area 2 and USA was Area 3. Well, actually it wouldn't be, because actually you need an Area 0, and that is referred to as your backbone in OSPF. So the UK was Area 0, and this was Canada was 1 and 2, and USA was Area 2. These would all just advertise the routes that are back there, so there could be like 0.6 route, 0.7 route up here in the USA, and it would only advertise, and you wouldn't need to know about the 192.168.2 computer here. It would just advertise, and the UK would send the packet up there, and then this router would distribute it to another router, and then it would finally get to its destination. One of the problems that you can have with OSPF is if you do not design the network in a hierarchical structure, that it won't really work. It has to be designed with a hierarchy in mind for it all to make sense. And all the routers in an area also have the same topology table as well. So as we were saying before about so another thing that OSPF has, so let's say we have a router and it leads to other stuff that's outside the network, so stuff like the internet or somewhere else, and these would be called an ASBR, and this would be called an autonomous system boundary router, and this would basically just communicate with the outside world or other networks per se, and not just ones in our own areas. So that's just another interesting thing about OSPF. Another interesting thing about OSPF is it's a lot faster to update its tables, and whereas other networks talk to each other like every 30 seconds, OSPF talks to each other in every 10 seconds. So now you've kind of got some of the core principles and ideas behind OSPF. Let's move on to implementing OSPF onto our current routers here. So let's start off up here with just the USA router. And these routers have nothing on them. They are just basic, just got their IP addresses on and everything. So we're just going to configure OSPF now and just show you how to do that. So once we're just going to config mode. So now we're in config mode. Now we're just going to type in same as what you did before. It's going to be router OSPF, and then we're going to need a number again. I've just spelled that wrong. OSPF, and you're going to need a number again, a lot like RIP, kind of like a password to communicate with each other on the network, for just basic for being basic here, we're just going to use the number 1 because this is only an example. And then we're going to want to advertise the networks. Now, advertising the networks on OSPF is a bit different to how you typically advertise something on like an ERGRP network or a RIP network. So we could actually go type in like the area, like the network to begin with, and then you go type in, for the sample of this network, we're just going to type in 0.0.0.255, and then we type in the area, which we are, this just be area 0. We're only entering area 0 for all of these just because it's going to be a lot simpler just to deal with, because this is only a small network, it's not a massive network that goes on forever. You can make this smaller, like the subnet mask and all that. You can make it more efficient by going into binary and breaking it down and trimming it down to like the most efficient range of like IP addresses and what have you, and subnet masks to make it really efficient and not be wasteful of IP addresses. But it's just a demo and the basic understanding of like OSPF. So we've entered the first network. We're just going to go on change these now. Just go down here and just we'll just add in all the networks, a lot like before. So we're just going to put 2 in here. So what we can do now is you can just type in 6 in there, and that is the end. And we can do show IP route, and as you can see, we've got some O's appearing in here now, just there, and the O in the table stands for OSPF. That's configured, and we can do that same command on all the routers, which we'll just do now. We'll come back to that one because it's just gone into silly. If you do enter the command in wrong, it does sometimes try to connect, and it's annoying, but it happens. As you can see, we've got another 3 O's for OSPF there, and now this one should have sorted itself out. Show IP route, and there you are again. We've got another 3 there. We take out a line and just give it a second to update, just fast forward a bit of time, and then take out these tests, and we just want to send a packet to here. It'll work, and then we should get a nice big green tick for it working, and there's the tick. Yep. So that just proves that we can still talk to each other with the direct line being crossed. So if we actually put that line back in, we go back to real-time mode, we just put that line back in, we should be able to see if now if we talk to those computers, fast forward a bit of time, just let the routing tables update nice and proper, and then we talk between this machine again, that the packet should go down the line like it has. Just skip that and it goes back. Once again, we've got another nice big green tick. So that's been me doing OSPF. Thank you very much for listening. So one thing I wanted to quickly mention was that how you could test from a machine, because I was just realised I was editing this video that I haven't really shown how you could do that. I've mentioned it like once or twice, but I'm just going to show you how you could test from an end device just to check around the network. And what we're going to be talking about is just the ping command. So as I was doing before with like the little packets in Cisco packet tracer, just sending them files around. But to do it from an actual machine, like if you were doing it in real life, you would just go to something like the desktop on a network, like this one here. So we're just going to go and open up the command prompt. If you're on like a Windows PC and you want to do is you just open the command prompt on there. And what you would type in, you would just type in ping, and we're going to just ping this computer over here, just this USA PC, and you just type in ping 192.168.6.2, and just let it send these packets out. Basically in here it's just going to send these packets out here, and it's going to wait for a reply from the other computer. So that's communication packets going from like this line from this UK PC along the network to this computer here. And it says here that we have sent 4 packets, received 4 packets, none of the packets were lost at all. And yes, this is like a successful test. But if you were to ping something that wasn't on the network, so let's say that we ping a 192.168.63 computer, that IP address does not exist on the network. It will just time out because basically there's nothing there to talk to get any sort of response from. So as you can see here, it's starting to say request timed out. And just fast forward that a bit. And you can see all the requests timed out, 4 packets were sent, nothing was received, and we had a 100% loss rate. So that's just one way you can like test from end devices to see if your computer is fully working. But you can also ping routers as well. So we'll just ping this Canadian router up here, ping 168.2, and that is the .2 IP address. And you can see we're getting replies back from that router there as well on the network. So that's just something I wanted to mention along. It's another form of testing. Like before, we mentioned the showing the running config to see testing to see which type of things were in your configuration setup, just to see if you'd made a mistake maybe. We also showed about the IP route, to see another way to test or see if your routing protocols are actually running, or what routing protocols are actually running on the network. I just wanted to talk about another testing type command that you could do on your Cisco network, to test the network. So what this thing is called, what the command's called, it's called trace route. And basically what it does is it traces the route the packets go, to talk. Traces where the packet's going, where the route is going on, which type of route it's taking to send the packet there, and where it's going. So what we're going to do is just type in trace route like that, and what we're going to do is we're going to want to track where a packet goes from sending it from this CA router down to this UK PC. So what we're going to type is the trace route, and we want to know the trace route for 192.168.5.2. And you can see that it just generated this route. So as you can see, it's saying that it goes from here down to this 192.168.31 network, which is the port on this UK router. And it goes from here to here, which is the IP address of our end device UK PC. So that could be really helpful if you've got a bigger network and you can see the routes a bit better. It's kind of like what we were doing before when we were when I was physically showing the packet going around the network, with the little envelope with the green tick on it. It's basically kind of like that, but it's more of a usable thing in a real life scenario type thing. So yeah, thanks for watching guys, hope you learnt a lot, and see you next time.